started here. Sorry for the technical difficulties this morning. Yeah, it just bothers me more than it bothers you guys, doesn't it? So here's the solution to quiz 3, which I will hopefully post in course content here before too long. I'll try to go through it rather quickly because I want to leave most of the time for working on problems we haven't worked on yet. All right, so let's see here. Make it a little bit bigger. So the first one is actually a problem I gave you before, right? So this was on quiz 2. So here's, I recycled this one. Hopefully more of you got it this time. I think more of you got it this time. Oh, duh. Perhaps I should actually give you your graded quiz, if I can find it. So I graded these pretty generously. Unfortunately, I haven't graded yours yet. Do you want to look at it while you're...
Yes. Well,
You won't change it, right?
No.
Okay, I'll trust you. Okay. Yeah, if you write in pen, that'll be fine. But I would have graded it. I just, I didn't have time. Okay, so. Yep. Okay, what? Ah. Hey. Oh, duh. What's wrong with me? I found hers first. I got distracted. That's what happened. I know you're here. All right, so number 2 here. Well, secant's 1 over cosine, and we're given cosine's root 3 over 2, so just put it in there, and so that's 2 over root 3. All right. I see from looking at your quiz, you guys still are quite a ways from internalizing the adding angles formulas. So, like, you need to do a significant amount more studying on how to use the adding angles formulas, right? So here we've got cosine, cosine minus sine, sine. So that's a cosine of a sum. So 41x plus x is 42x. Down here I've got sine, cosine minus cosine, sine. So that's like a sine formula. And because of the minus, it's the difference of 4x and 3x. So that simplifies to sine x. All right. The next one is a sum of sines, right? So if I had my handy-dandy formula sheet out here, I could refer to the number for you. See if I can find it. So I saw some of you kind of like half remember something and tried something, but it didn't quite happen, right? Let's see here. So this one, problem 5, is from sum of sines, right? So that was formula 27 on the formula sheet. And so formula 27 says sine plus sine is a product of sine of the average times cosine of the difference divided by 2. Both of them divided by 2, and there's a 2 up front. So that's what I did. Problem 6, you got a product of sine and cosine, so you want the product to sum identity. Sine times cosine, so that was number 26, which is going to give you 1/2 sine of the sum plus sine of the difference, which is what I did. But then I used the fact that sine is odd to pull out the minus, so I got sine of 15x minus sine of 7x. All divided by 2. Problem 7 is actually easier, right? Because problem 7, you just use even and odd for sine and cosine to pull the minus out or to absorb it. And that gets you a minus minus, which is a plus. You got 2 cosine sine, but that's one of the more famous identities that we must know about. We should have this one memorized. 2 cosine sine is sine 2x. So for what it's worth, that is formula 15, replacing theta with x. Any questions? Yeah.
What is negative 2 plus sine negative x simplified to?
Sine 2x. Yeah, because we get Well, the 1 minus, since cosine's even, we just absorb that. Cosine of minus x is equal to cosine of x. The other sign, we pull the minus out because sine is odd. That's why I write minus sine x over here. And so you got minus and minus, which gives us plus, and the 2 is still there, so 2 cosine sine is sine 2x. Yeah. Yeah, I think some of you were closer to this. I think I gave you like a little bit more for this for a couple people. This one, so up at the top, I'm just thinking through, like, wait a minute, what does this mean? If theta is in quadrant 3, that means theta is between, you could either say pi and 3 pi over 2, or you could say minus pi and minus pi over 2. Like, you got different ways of presenting the standard angle, right? Whichever way you present it, if you multiply by 2, you're between 2 and 3 pi, or between minus 2 pi and pi. And if you think about that, that kind of tells you something about where sine, what the value of sine should be, because between 2 pi and 3 pi, sine is positive. All right? But I should expect a positive number. That actually didn't matter. Like, it all kind of, I didn't actually have to refer back to that in my solution. So, like, what's up at the top of the page is kind of extra. All right? But there could be another problem where you need that information. It doesn't come up too much, but there was another problem where we're given the range for theta, and we had to multiply the inequality by 2 to see the range for 2 theta. All right? So just be aware of this. I've seen this cause trigonometry teachers to get confused about why the problem was wrong. Like, this is an insidious issue that if you forget that the domain of theta and the domain of 2 theta are different for a given problem, it's one of the most, like, sort of hidden kind of insidious errors that you find. Anyway, so solve for cosine. I get cosine's plus or minus square root of 1 minus sine squared. But because we're in quadrant 3, I know that cosine is negative, because quadrant 3 is here, where cosine is negative. So I do minus the square root of 1 over 25, which is the square root of 24, over 5, with a minus out front. And then I can put it together, and voila. So, yeah. Again, using the sine 2 theta identity. See, this is very unfortunate. Like, I should have made this one be the cosine 2 theta identity or something, right? The last problem was cosine 2 theta, so I'm kind of overemphasizing the sine 2 theta identity, but my bad. Problem 9 is very similar to one we worked in class. In class, I worked cosine to the 4th. This is sine to the 4th. It's pretty much the same calculation. You put in the half angle identity for sine squared 2 times, multiply it out. That gives you a cosine squared. Use the half identity on that again. So you have to double the 2 theta to 4 theta, and you get a half. Put stuff together, you get 3 halves minus 2 plus a half, and multiply the 4th through, you get the answer. So. And the last one, you just have to kind of work through it. I mean, the key here is that the sum of the angles in a triangle is 180 degrees or pi radians. So I know alpha plus beta plus gamma is pi. But, so I can trade alpha plus beta for pi minus gamma. And then I've got a sign of a difference, so I can use the adding angles or the subtracting angles formula for sine if you like, which gives me sine pi cosine minus gamma plus cosine pi sine minus gamma. So I use the adding angles formula on minus gamma. I didn't use the difference formula. Anyway, there it is. But of course, sine of pi is 0, cosine of pi is minus 1. And so we get, but the sine is odd, right? So I can pull the minus out of sine minus gamma. It gives me minus sine gamma. So sine gamma. So that's that. I still don't know how to do that triple tangent problem. Of course, I still haven't really looked at it that hard. So if you figure it out, let me know. Okay, so that's it. Any questions? All right, so let's dig into section 7.5 problems. I don't really need to teach you any new trigonometry here. This is just an application of the trigonometry we've learned. What I might need to teach you is some new algebra ideas. to solve these problems. We'll see. So let's just dive in, see where we go. So for the following exercise, find all solutions on 0 to 2 pi. So I'll start with number 9. So find all solutions of tangent of x equals to 1 on, 0 less than or equal to x less than or equal to 2 pi. All right? Actually, we don't include 2 pi. He has not included 2 pi. So alternatively, you could say x is an element of like the closed interval from 0 to 2 pi not included, if you wanted to state it in terms of like sets and elements and such. Okay, so what do you guys want to do? How about we take the inverse tangent? Yeah? Inverse tangent of 1, what is it? So x equals to, put it in your calculator, you get out pi over 4. Right? Pi over 4 is the inverse tangent of 1. Now, what's the key property of tangent? The tangent of x plus n pi is equal to the tangent of x for all integers n. In other words, tangent has period pi. It repeats itself over and over, pi, right? So let me graph that. I think, for myself anyway, to feel comfortable with these problems, I find myself always drawing a graph to verify my logic. So this is pi over 2, right? Pi, and so you shift pi over, you got a vertical asymptote again, 3 pi over 2, right? That's the next time cosine is 0, right? And so tangent has 0 at 0 and at pi and integer multiples of pi, right? So, and then of course, what's next? 5 pi over 2, right? So this is 0, this is at pi, this is at 2 pi, right? So how can I picture solving tangent of x equal to 1? Well, when we look at tangent of x equal to 1, one way to understand that is it's where the graph of tangent intersects with the graph of y equals to 1. So y equals to 1, that's something like this, right? What is the, where are we interested? We're only interested in 0 included, right, here, all the way over to 2 pi, right? So we found one of the solutions already. We found this one, right? But there's another one here, isn't there? Should we include that one? We should not, right? It's outside the 2 pi. It's past 2 pi. We're not interested in that one. So we see that x equals to pi over 4 plus pi is also a solution. So 5 pi over 4. So in other words, solution is pi over 4 or 5 pi over 4. Or I could say and pi over 4, I should say. I'll say and. There you go. So everybody should be able to find at least one solution, right? Finding the second solution requires more finesse, right? I mean, but that's what you want to get to. Let's try number 12, cosecant squared same section. Cosecant squared. Cosecant squared x equal to what? Well, minus 4 equal to 0. So what I would do with this is go, okay, so that means that cosecant, I mean, there's various ways to go here. Cosecant squared of x is equal to 4, right? So that tells me that cosecant of x is equal to what? I keep writing CC. What's wrong with me? Cosecant of x is equal to plus or minus the square root of 4, right? Also known as plus or minus 2. I'm definitely going to want to take a graphical approach here, so let's graph cosecant. What's cosecant? And let me stop. We don't care about negative values. Let my graph focus more on where I care about. So I'll put 2 pi over here. All right, so cosecant is what? 1 over sine x, right? That's what we're thinking about here, cosecant. Where does that have vertical asymptotes? Where is sine 0? Nobody? It's very unstable today. It's weird. Well, all right. You guys make me do everything. Here. So sine is 0 at 0, right? So we've got vertical asymptote at 0. It's also got a vertical asymptote at pi, at 2 pi. Right. Sine of any integer multiple of pi is 0. So that's where my vertical asymptotes are. And remember, it's 1 over sine, so as I discussed, if you look at 1 and minus 1, right? It has to be above and below those lines. Can't go in between. There's a problem in your homework that's like, calculate the inverse secant of 3/5. The reason that doesn't make sense, you have to take inverse secant of something that's in the range of cosine. Well, the range of cosine, excuse me, you have to, way around. You have to take something that's in the range of secant, if it's the inverse secant, right? The range of inverse secant does not include numbers of magnitude less than 1. So like somebody asks you to take the inverse secant of 3/5, you should tell them to go fly a kite. I mean, that's a nonsensical question. That's why in the back of the book, that one has no solution as the answer. I was working through it this morning with one of you guys, and I got to this triangle where the hypotenuse had a shorter length than the adjacent leg, and I was like, what? What have I done wrong? I didn't do anything wrong. The problem was, the whole point of that problem was there was no solution. Anyway, okay, so sine is positive here, so it's got a graph that's, sine basically does this, and then that doesn't meet that line. It's like, I can't. Then it does that, right? This is pi over 2. This is 3 pi over 2, right? So how many solutions do we expect here? Here's, let me try blue. Blue doesn't always show up that great, but I'll try it. So 2 is like up here, right? And minus 2 is down here. I guess I better do those again in white. Otherwise, people at home won't see it. There we go. So here's 2, and here's y equals to minus 2, right? So I expect 4 solutions here. 4 solutions. I should get 1 here, 1 here, 1 here, and 1 here. So let's start out with the 2 one. So we've got cosecant of x equals to 2. That means that 1 over sine of x is equal to 2. That means that sine of x is equal to 1/2. Well, that I can solve. that says x is equal to pi over 6, right? That I know. I've memorized that by this point in the course. That's a standard angle. So the first solution, the one that's closest to 0, is pi over 6. By symmetry, the one that's over here, the next one, 5 pi over 6, right? Because that is pi minus pi over 6 gets star. I'll put a star right here. See that star? It's the same distance from 0 as it is from pi. So I subtract pi over 6 from pi to get that point right there. Okay? There's 2. What else? I think you can see from the symmetry of the graph, this must be what? Pi plus pi over 6, right? And this guy over here must be 2 pi minus pi over 6. See, so once you've got the basic solution of pi over 6 and you understand the graph, you generate all 3 other solutions from the symmetries of the graph. So cosecant. And then, of course, after you're done with all this stuff, you can check your answer, right? You could plug it into the handy-dandy calculator and see that you actually do get what you want. I'm not going to do that because we got to go on. That's how many sixths is 2? 6 is 2 is 12 sixths, right? So 12 minus 1 is 11 pi over 6. So there's number 12. Is there a particular one in this section you guys would like me to try to solve? No? All right, let me move on here and try number 17. Ooh. All right, fine, I should do it. Section number 17 of section 7.5. Here we're asked to solve 2 sine of 3 theta equal to 1. And what are the strings attached? Well, we're supposed to solve it on 0 to 2 pi. So the way I think about a problem like this, I ask myself the question, okay, if theta goes from 0 to 2 pi, what does 3 theta do? Another way to think of this is, how would you graph y equals sine 3 theta? So what's this? Someone left us a palm tree and I guess a tree maybe. So think about this, guys. When is sine 3 theta going to reach that point I just checked? That should happen when 3 theta equals to 2 pi, right? Because that's when we go full cycle. So that tells me that that's actually 2 pi over 3, right? And so this is halfway there. So this is pi over 3. This is, let's see here, over here. Let's see here. So pi over 3 for each hump or valley, right? So 2 pi over 3, this is pi. Add another, so I got 4 pi over 3. I got 5 pi over 3, right? Rats. So it looks like we got more to think about for this one, don't we? Because it takes all the way over here to get to 6 pi over 3, which is also known as 2 pi, right? So this is the graph of y equals sine 3 theta when theta ranges from 0 to 2 pi. We've got 1, 2, 3 whole cycles. Okay? Now, this problem is just like the other ones we've worked. Really, it's the question of when is sine 3 theta equal to a half, right? Well, again, this is special angle, right? So I know that that means that 3 theta must be pi over 6, because pi over 6 makes sine equal to a half. So one of my solutions is theta equals to pi over 18. Where is that in this picture? Well, I guess I haven't drawn the let me put the half in, right? There's y equals a half. So we're looking for these points of intersection. Those are the places where we solve this equation, right? And so I think we just found the first one, right? So pi over 18. What's the next one? How about this? Pi over 3 minus pi over 18, right? By the symmetry of the graph. That should be that point, because it's the same distance from the origin as it is from pi over 3. So I would do pi over 3 minus pi over 18, which is 5 pi over 18. So there's another answer. Here's the first answer. How many answers are we going to have? 1, 2, 3, 4, 5, 6 answers. So next up, we do 2 pi over 3 plus pi over 18, right? And we'll do, oh, wait a minute. Did I do that right? Yeah, plus pi over 18, right? And then pi minus pi over 18. And then we do 4 pi over 3 plus pi over 18. You see why I'm doing subtraction and why I'm doing addition for each one, I hope. And there you go, like whatever those work out to. 12 plus 1 is 13 pi over 18. 17 pi over 18. 12. Oh, 6, no, 24 plus 1. 24. 25. Pi over 18. 29 pi over 18, right? So there you go. There's the 6 answers to this problem. All right. I want to look at one which is a little. I think all the problems I've shown you so far, they're kind of the same kind of story. Oh. Would it be better to have the quiz on Wednesday? Yeah, I can make the quiz on Wednesday. I just I won't be able to get it graded before the test probably, unless you come pick it up Thursday, you know. So. But I will. What I'll try to do is give the quiz on Wednesday, and go over the solution to it on Wednesday at the same time. So that kind of. And so the quiz on Wednesday should cover, well, pretty much all the material since test 1. But it probably will focus more on section like 7.5. Did I assign you guys 7.6? I think I might not have. Did I already assign problems in 5?
Yes, you assigned problems in 5.
Okay. Which problem did I assign in 5 between like number 23 and 32?
You have
25?
29, and 31.
Okay. Let's look at 25. So these ones have been, I think all of these problems we've looked at so far I would classify them sort of, well, with the exception of this one. This one was nonlinear. But most of them have just been kind of like trig function equals number, right? So you just kind of look at the graph and figure out where the number is. But a lot of times there's a algebraic, what's the word? Issue you have to settle first. And this is one of those. And so like sometimes, so I got 2 cosine squared t plus cosine t equals to 1. So in a problem like this, what you want to do is you want to make a substitution. All right? Because if we look at this problem, what we're looking at is a problem which is quadratic in cosine t. See, this is quadratic in cosine t. So what we can do is just let x equal to cosine t. And then we've got the equation 2x squared plus x equal to 1. And we know what to do with that. That's a quadratic equation, right? So we've got 2x squared plus x minus 1 equal to 0. And maybe we can factor it, maybe we can't. I don't know. I'll try. So 2x, x, maybe I can do it like this. I got to put a 1 one place and a minus 1 the other. How about I do this? I think that works because I get minus x plus 2x. Yeah, factored. All right. So that tells me x, that's 2x minus 1 equals to 0, or x plus 1 equal to 0, right? Which is to say that 2x equals to 1, or x equals to minus 1, which is to say x is either a half or x is equal to minus 1, right? And what is the context here? Where are we supposed to find solutions? It says on 0 to 2 pi, right? Again. So you see, we have to solve 2 problems. We've got to solve, so this is equal to cosine t, right? And this is equal to cosine t. So we look at the graph, cosine t. We got to face, where is it equal to a half? Here and here, right? But also we have to face, where is it equal to minus 1? So minus 1 is different than a half, isn't it? Because minus 1, unlike a half, is only reached at 1 point, isn't it? In fact, I can tell you that this says t equals to pi. That's the only solution from that piece. Now, cosine equal to a half, that's a special angle. So I get from the orange, I get t equal to pi over 3, or 60 degrees. That gives me this point, right? And this one over here, well, by the symmetry, you can see, or t is equal to what? I take pi, and I add pi over 3, right? That gets me to here, I think, if I do my graph right. Wait a minute. No. No. Careful. No. Maybe not. I don't know. So sorry, guys. This distance, whatever that is, I think should be the same as this distance, right? So what's this distance? That's pi minus pi over 3, right? So that's 2 pi over 3, right? And so this distance should also be 2 pi over 3. So I should do pi plus 2 pi over 3. Don't let me trick you. So we get t equals to 5 pi over 3. So there you go, 3 answers for number 25. It's kind of funny. It's sort of quadratic equation with 3 answers, isn't it? But it's not quadratic in t, right? It's quadratic in cosine t. And the truth of the matter is, if you extended the domain of consideration, instead of 0 to 2 pi, if you made it like all real numbers, how many solutions would you have? You'd have infinitely many, because it would just go on and on. Let me try to find another one kind of like, let me try to find one which is slightly different. 26 is the one I... I'll tell you what, let me do a... 26 is still just like a quadratic one. It's just, for number 26, I'll just give you a hint. You need to use that tangent squared x plus 1 equal to secant squared x. So like that number 26, it's got a secant and a tangent in it. So like convert one or the other to the other, and then you'll have a quadratic equation either in secant or tangent. Okay. But what I wanted to look at was maybe number 35. So you've got cosine 2x cosine 2x cosine x plus sine 2x sine x. And all of that's equal to 1. And again, you're supposed to solve on 0 to 2 pi. So what should we do here? So I know you guys are shaky on this because I looked at your quizzes, but what identity should we use? So it's almost like the cosine adding equation, right? But it should have a minus in the middle. It doesn't, right? So this would be number 13, right? Number 13. With 2x equal to a and x equal to b. So what we're looking at is the cosine of 2x minus x equals to 1. So actually, look at this. This is really just solve cosine of x equal to 1 on 0 to 2 pi. Now the not included really matters. So again, I always fall back on graphs, guys. So this is part of the reason I felt like I didn't really need to do too much graphing early in the course, is because I know I'm going to get back to this eventually, and I'm going to do nothing but draw graphs for every one of these problems. Like you may have another way of doing it. Like some people can just reason through, use the periodicity and just algebra statements. But for me, the proof is by the picture. It's very helpful for me. I don't know. So if you look at this, here's 1, right? So there's 0, and over here is 2 pi, but 2 pi doesn't count, right? So the answer is x equal to 0 is the answer. So I guess we'll stop there for today, but you know, the methods I've showed you, you can use to pretty much solve all the problems in this section as far as I know. So try them out. So anyway, have a good weekend. Oh no, you get to keep. No, you guys keep the, except for her. I need. If I've graded your quiz, you can keep it.